Hear from Gregg Young, certified professional agronomist and pest control advisor. Take it away.
Is my screen up there?
Yeah, we see you.
Yep. Oh, okay, good. Hi, this is Gregg Young, and a little background. I actually started working for Rincon Vitova right out of college in 1972 and moved up to work in their North Coast operation, Mendocino-Lake, Sonoma, and Napa County in 1973. And then, so Deke was definitely one of my influences. And then one day I was down here and he walked in with a book called the Albrecht Papers and said someone gave him the book and would I please read it and explain it to him because he doesn't have time. So I ended up doing that and getting very heavily involved into the soil fertility end of it, along with the pest control advising business. So, and then about 1995, I started working in Contra Costa County in the stone fruits and other crops. It was mostly apples, pears, and grapes up in the North Coast. And then about 5 years ago, I started working a little more down here in Ventura with citrus and Mediterranean crops. Okay, so the disease triangle, it takes all three components for disease to affect, and it's the same with pests. And so we're going to focus on susceptible host here. So often in IPM, we spend our efforts monitoring the diseases, the weather, the pests, the life cycles, and we don't know all the factors that are impacting the susceptibility of the crops. And if you're a pest control advisor and been doing this for a while, there's probably times you've walked into an orchard or vineyard or crop and it's just going crazy with pests or diseases and you just think there's something really wrong here. And so I've had that happen several times early in my career, and at some point I started looking into some of these other factors. So all of the biomass that makes up mature tree or vine comes from the soil. So you could have a 2-pound tree, and then 10, 12 years later, you have a 425-pound tree with a large crop that you remove every year. And so I've heard people say that pests and diseases has nothing to do with fertilization and soils, and actually it has everything to do with it. And then now modern agriculture, we're trying to squeeze the most we can out of this whole system. And so we've got the trees, their roots are virtually intertwined and they're competing with each other and the cover crop. And then we're hauling off these giant crops. So it's good to study the natural systems and try and apply those, but we got to remember this is kind of unnatural because we're really stressing these systems with our cropping. And again, when they used to use flood irrigation, then the trees would be out there in the middles and using mostly orchard floor. And then we create compaction and we have natural limitations. And so these are all things that we have to deal with. Here's some of the early pioneers who called for attention to soil fertility and managing pest diseases. William Albrecht said, food is fabricated fertility. And that's a real cute ortho ad where they're just sitting there, hi honey, let's get rid of these bugs. Those days are kind of gone. Okay, so ever since the 70s and even before, some have been associating mites and pest problems with fertilization, especially nitrogen fertilization. Let's see if I can get my thing working there. Okay, and then they also started studying calcium in relation to physiological problems and things in fruit and various crops, and they are finding that nitrogen stimulated growth can aggravate some of these problems in nutrition. And again, the mineral nutrition that not only influences the balance, the yield, but also the quality, and it determines the susceptibility to diseases. In orchards, it's they've known for a while that over-fertilization of orchard crops is the standard. It's not an aberration. It's pretty much the standard. And they know now. They've been doing research and trying to cut down on nitrogen. And now in some areas they have to, because you have to get a permit just to put on nitrogen, because it's starting to get into groundwater, and they see that, well, it may not be a problem now, 100 years from now, it will be a huge problem once it gets down in the deep aquifers. So, all right, so this is one of the important things that William Albrecht and the early soil researchers came up with, as the idea of cation exchange and the ability of clay to exchange nutrients with plant roots. And so they'll send out roots, and they'll, through direct colloidal exchange hydrogen for calcium, magnesium, potassium, and in some cases sodium and things they use. So this little diagram is showing roots growing, and they're trying to intercept 10 calcium here, because the roots need a constant supply of calcium for the fibrous roots. Okay, so when they get into a high magnesium soil, for instance, they need to grow farther and exert energy. So say they have to grow twice as many fibrous roots. Now the plant will do that because calcium is part of the skeleton, and it has to have that. And they'll also do it with potassium and other nutrients it has to have. But if it's having to do that, then it cannot possibly resist diseases and pests up on the upper parts of the trees at the same time that it's having to exert more energy than it normally would. Another important thing is soil nitrogen content ranges from 1,700 to 6,800 pounds per acre foot. I have a better view of this. So here, a 1% organic matter soil has 34,000 pounds of organic matter. Of that, about 1,700 pounds is nitrogen. A 3% organic matter soil can have as much as 5,100 pounds of nitrogen out there. But then they consider that only 2% is available per year. And that's really not very efficient. If we went through school and we only got 2% of our answers right on our tests, we would be repeating a lot of classes. So what we want to do is we want to get closer to this over here. We're never going to get all this nitrogen, but we don't need that. Most crops only need between 50 and 200 pounds of nitrogen. So there's a lot of room for improvement. So here's what you need. You need abundant phosphorus, potassium, calcium, magnesium, sulfur, and micronutrients. You need optimum calcium, cation balance. You need optimum soil aeration, and you need optimum soil bioactivity to get closer and release more nitrogen. And again, here's the nitrogen cycle, and this is up in the corner of every high school biology classroom. But the important thing is organic matter breakdown needs oxygen, protein synthesis needs carbon dioxide, and nitrification needs both. So that the nitrogen cycle works best in well-aerated soils. Potassium, for instance, is a very important nutrient. It's not stored in the plant. It's necessary in the cell sap, and as fruit ripens, becomes a potassium sink. You need a constant supply as the fruit matures. And again, calcium is needed for root growth, constant supply. Potassium has been known for a long time to increase disease resistance. Over 140 diseases were reduced by potassium. Okay. Sorry. Okay. And again, calcium is an important part of the skeleton of the plant. It increases cell wall strength. Tissues higher in calcium have stronger cell walls, are firmer, and resist infection more readily. Okay, so I think I've made that point. Now, what do we use it as fertilizer? So in California, these are fertilizer sales 2018. Nitrogen was 68%, potassium 23%, and phosphorus 9%. That's our big NPK. Ventura County, nitrogen 81%, phosphorus 6%, potassium 13%. In the United States, the ratio of nitrogen to phosphorus and potassium has been steadily rising for the last, 55 years. And now we're up where overall in the United States, phosphorus is almost 3 times that of potassium. Nitrogen is almost 3 times that of potassium. So we're using a lot of nitrogen in agriculture. That's not news, I think. But what does citrus need? Well, in Australia, they recommend potassium slightly more than nitrogen and about twice as much for calcium. In California, they generally call nitrogen and potassium use about the same, and then calcium's third, although a lot of references don't even really talk about calcium. I know the reason for that, but we won't go into that. So, but what do crops really need? So as far as oranges and assorted citrus, it's basically nitrogen is roughly equal to potassium, which is greater than calcium. But then if you figure the trees with their roots, their trunks, and their leaves, then it's actually calcium is more than nitrogen, which is about equal to potassium. And that's considering all these other things in the orchard. So this is one study says there's an agreement that calcium, nitrogen, and potassium are the dominant constituents of citrus tree biomass. And that's a lot more than magnesium, phosphorus, and sulfur. So if your soil grew citrus on it for 50 years, it would have removed 3,500 pounds of calcium, almost 3,000 pounds of nitrogen, 2,300 pounds of potassium, 350 pounds of phosphorus. My little dog came into the room. Okay, was all this replaced? And that would be a sustainable operation. And of course, what about micronutrients? Then as we reduced our water use through drip and other forms, this is drip irrigation, which isn't used much in citrus, maybe in young trees, but we end up with a small pyramid of water underneath the soil. But in the top foot of the soil, the bacteria are all up there concentrated, and so are the feeder roots of most plants. So you actually have a kind of an inverse relationship where the wetted part, especially in the summer, is down lower, and then all the bioactivity up here is not getting wet. And it's kind of the same thing with I used to use flood irrigation, but now we're using misters and smaller systems. So that just makes the nutrition and the balance of nutrients even more important. So basically in the summer, all those nutrients have to come from a smaller area. Okay, so I think we've shown the importance and increasing importance of nutrition and mineral balance and things in our tree crops. So this was breakthrough. This should have been front page news. This came out in 1995. They did 4 years of research in nectarines, University of California, found that excess nitrogen raises the susceptibility to diseases and pests. And they did a photomicrograph, and here's the thinner excess nitrogen, get a thinner cuticle in the fruit, made it more susceptible to brown rot and also to their 2 main pests, the peach twig borer and the oriental fruit moth. And what I say is this principle should be applied to all crops. Excess nitrogen aggravates many problems. There's a high likelihood that excess nitrogen is being applied, and nutrient budgets should address all the other nutrients. And then we have all these problems in the industry that we come popping up, and they usually pay the universities to study these. So about early on, sometime in the early 80s, I started collecting articles that I would find relationships of nutrients and pest and disease problems. And so I came up with about 15 insects, diseases, and nematodes and wrote a little paper on it. And so then since then, I started, this is kind of a strange hobby, but and then especially as we were able to use computer searchers and now just Google Scholar, you can just put in keywords and things. So over the years, I developed a list of 500 references and relationships between nutrition and pests and diseases and physiological disorders. And this is just on tree fruits and vines, deciduous tree fruits and vines. 59% show high nitrogen aggravates the condition. 28% show low calcium aggravates the condition. 12% show low relationships with potassium. And there are a lot that involve micronutrients. So I now have 294 studies and articles in deciduous trees, fruits, and vines linking high nitrogen with increased pest diseases and physiological problems. And I figure if we went through those, we could probably throw out some and say, well, they're quoting other sources and they're repetition. And so let's cut it in half, and that's still close to 150 studies showing this. And then we could go through and say, oh, that's not peer reviewed and blah, blah, blah. So there still would be at least 50 solid studies linking high nitrogen with increased pest and disease problems. And I will get back to citrus, but here's a typical pear orchard with 24 to 48-inch shoot growth. That is the standard growth. Most books recommend 12 to 24 inches. Here's a pear grower I work with. Here's a 2-foot shoot in pears. We're trying to keep it minimal nitrogen. And this is in early June, and you still have July and August of growing shoots. So it's very easy to overstimulate trees. Okay, so then for this project, I worked over the winter. I came up with 200 interactions in citrus between nutrients, soil conditions, and pests and diseases. So the results, about 104 say high end makes it worse or low end makes it better. About 12% say calcium makes it better. Yeah, so 52% of these references and studies, and 15% say potassium's involved, and there's 11 references on silicon involvement. Okay, and then as far as just insect mites and nematodes, again, this is just in citrus, there's 41 references showing high nitrogen aggravates the pest problem. There are also 7 that show that low nitrogen aggravates the problem. So definitely there's a balance that needs to be there. I forgot to correct this. There's actually 42 references. Notice the aphids building up on the leaves. They know where right on the veins, they know where the rich food is, and they're really loving it there. Then what about silicon? I've been ignoring that for years and thinking about it off and on, but now this year I'm getting serious about it. I've done tissue analysis for over 40 years and never asked for silicon in it. So in all my customers now, we're going to be analyzing for silicon and trying to learn something about that. So, 3 citrus diseases responded positively to increased silicon. 4 studies showed a decreased resistance to insects with succulent using high nitrogen shoots. 5 studies show increased resistance to insects in citrus with increased silicon. And then diseases, 61 references relate nutrition to disease incidence. 25 say high nitrogen makes it worse. There's 10 studies linking nutrition with HLB, and there are several not showing improvement using fertility management. But I think we really haven't given this a real good look yet. There are studies in citrus linking excess nitrogen with succulent shoots and leaves, and that results in increases in at least 4 citrus pests, including citruscillas. So how do we get out of this excess nitrogen growing system and into one that's more balanced and is going to create healthier crops and more pest and disease resistance? Well, one way is that we want to come up with a minimum fertilizer needs, and we need to consider what's removed by the crop, including seeds, skin, stems, woody parts, and roots. So basically, I think it's fair to say that nitrogen is equal to potassium, which is greater than calcium, and of course consider the micronutrients. And if we went back to the fertilizer sales, we see that that is not occurring as far as actual applications of fertilizers. But the minimal fertilization program should replace the nutrients removed by the crop. And there's no one who can convince me that that's sustainable if you're not replacing what you remove by the crop. Okay, so how are we going to do this to ensure optimal quality, flavor, and health of our trees? Another aspect is the newer biological materials. They often offer 80 to 90% control, and sometimes more, and sometimes that's not good enough for some of our grading systems and goals in IPM. But what I'm proposing is that making a healthier, less vigorous host is going to make better control with these softer materials. And I have seen that in the crops that I work with. So here's what I'm proposing. I wrote this down in 1988. It's not really my program. I learned this while I was working for New Era Farm Service, but I've been using this since 1979. So we want to balance the soil exchangeable cations to 65% calcium, 65-75, 10 to 15% magnesium, 2 to 5% potassium, and low sodium, with the appropriate mineral amendments. And you want to tweak this for your area and your crop and sometimes your economics, but keeping the calcium high in relation to magnesium is pretty important. And in tree fruits, you really want to be up here in this range, not the lower range, because they remove so much potassium. And sulfur and micronutrients at generous levels, but not excessive. Build and maintain organic matter through cover cropping, addition of composted organic matter, and or microbial soil inoculants. So we want to promote healthy biological activity in the soil. We want to supply nitrogen in adequate amounts for crop needs only. And so that's something that's not being done out there. Avoiding excess soluble nitrogen, applying it sparingly in split applications or via composted organic matter. And we want to use foliar feeding of nutrients known to be deficient, applying during stressful times, bloom maturity, adverse weather, and pest disease pressure. So cation balancing is controversial. There's not enough applied research, and it can't just be on yield, because we're not going for just yield, we're going for healthy crops. However, here are some facts. The major soil cations, they all interact. When one is high, others are out of balance. And that's real classic. They know when sodium gets too high, it's problems with the plant, and so they flood the root zone with calcium. But we pay attention to all these and try and keep in the best balance. These ratios affect the soil pore space, so drainage and tilth. And especially, again, calcium is related with either high sodium or magnesium. And that takes us back to the nitrogen cycle and the need for aeration to make things work properly. So poor drainage and soil aeration adversely affect nitrogen, phosphorus, sulfur, and potassium cycling, and no doubt micronutrients and other things. And all of these affect pest and disease resistance. So why not use the one that most soil labs used to show on their soil analysis report form? Most of them don't anymore, but these were developed by the early researchers, William Albrecht and others, and he put a lot of research into it. I don't have time to go into that, but way beyond just yields. And then fine tune these and modify according to your specific conditions. So again, this is just more backup. Calcium is essential for good soil structure. You need to balance it in the organic matter, or sorry, in the irrigation water. You can actually save water by using this method. Get increased oxygenation in the root zone. This is another article who's just backing up what I have just said. Cation ratios are valuable for fine-tuning fertility programs, solving problem soils, poor structure, tilth, and drainage, developing programs with lower nitrogen inputs, and that's one of our main goals here, and producing quality, and that's one of my main goals with my clients, and improving organic matter management. Here shows putting on limestone on an orchard, injecting gypsum through irrigation, putting it around small trees, give them a boost, building and maintaining organic matter. Here's a compost tea injection system, putting on regular microbial inoculants. Here's putting on compost in the vineyard, and putting compost right under the dripper. There's lots of ways to do this. And again, there's different ranges on what citrus needs, but we want a well-formulated nitrogen budget. And then once you get some of these other things going, the bioactivity and the good tilth and mineral balance, then you find you can cut down on this. So roughly they recommend citrus needs about 150 pounds of nitrogen, a little bit more of potash, and a little bit more than half that of calcium. Okay, I'm whizzing through a lot of this quickly, but the compost is controversial. I was there in 1979 using it on 1,000 acres and had to wait 10 to 15 years for the rest of the research institutions to catch up and recognize it as a valuable fertilizer. However, then they did a study and they said that most compost only releases 10% of the nitrogen the first year. And that's just totally wrong. There's thousands of acres in California, maybe even definitely tens of thousands and maybe hundreds of thousands that contradict that. It just isn't true. I wasn't able to find out all their methodology that they used for this one study, but it's just wrong. And it's being rubber stamped into what I call rubber stamp science, where everybody's quoting that. And what I found is it's yard waste compost. It's made by a company to get rid of yard waste. It's often not inoculated and usually not formulated for agricultural use. So it's not blended with manure and great pumice or cotton gin trash or other things that would boost the nutrient level of it. And so it's good that they're using it. I'm glad that it's the best way to get rid of yard waste, and it's good that they're starting to use this in farming, but it should not be judged against a good producer of agricultural compost. And then foliar feeding, again, that's just spraying nutrients on in a timely method. It can compensate for soil or other deficiencies, and it can be and is be used to augment resistance to pests and diseases. And let's not forget micronutrients. At least 25 references, and I wasn't really searching for micronutrients, but in citrus it shows that they influence pests and diseases. And what about silicon? Now there's several products that are registered for use as fertilizer. This company is saying it alleviates heat stress, drought resistance, thicker leaves. That's going to help your pest disease problems. And I think we need to put some serious research into this. And Rudolf Steiner started promoting silicon in 1924. And all biodynamic growers use a very rich silicon preparation to spray on, derived from equisetum. And it does protect against some diseases. It's registered as a pesticide for powdery mildew in a variety of plants. But it also protects against bacterial and viral infections. It also reduces the populations of insects and mites feeding on silicon-treated plants. For many years, they thought it was just making the plant cuticle thicker, but now they've shown that it's altering some aspect of the plant material, so it's acting to produce a systemic acquired resistance or some sort of form of that. So back to nitrogen. So here's the worst thing you can do. Just throw in one application for the whole season. And I doubt if any citrus growers do this anymore, maybe for young trees, but it actually is pretty common in the pears and apples up where I work. What's even better though is split nitrogen applications. Better than that is fertigation 4 to 6 times with foliar applications, and that will help you cut down on the nitrogen. Even better than that, nitrogen fertigation with very low rates of phosphorus and potassium as needed, microbial inoculations, and multi-nutrient foliar sprays. And the best, again, when I'm promoting 1 to 2 agricultural compost applications, mineral balancing, supplemental nitrogen if needed, and a lot of tree fruits I'm finding that's not needed, but there are always blocks and things that need a little boost. Microbial inoculations, foliar sprays of all applied nutrients likely to be needed, applied before stressful times. And this is my little movement quality first. And what we're actually finding is that we get comparable yields to commercial peach, cherry, and other growers. And there have been studies on flavor in wine grapes, especially where they pay a lot of attention to it, and various nutrient components of producing flavor. So if you would like a comprehensive analysis of this approach, my master's thesis is online at www.qfirst.net, and that reviews the work pretty extensively of Albrecht and the early soil scientists, and also the critics of that. It goes over both sides of that, and it has actual lessons in how to take a soil test from a lab and make recommendations for balancing the soil cations, and it goes into using compost and cover crops, using foliar feedings, and why you can cut nitrogen usage 25 to 75%. And if I get time, I will update this. So I think I'm on time. I'm going to close with this one quote I like. You don't have to know everything about the fertilizer industry and all the chemical reactions. You can't get something for nothing. Plants always require the basic components of plant growth from the soil in order to thrive, and that's what I like about him, is he's recommending not just grow and not just yield huge yields, but to thrive. And that is it.
Oh, great. Hey, put that slide back, would you, Greg? So
What do I do?
yeah, that the one right before that with the links.
Yeah.
Sorry. That was great. Yeah. And Brett, we have the links in the Google Doc for Gregg's publication, especially the Quality First. It's just been a mainstay for so long. if
And
you,
this, by the way, this show will be put on my website in a few days. So.
all right. I want the links to your two great manuals in the chat. So we'll get that in there. Well, that's a lot of ideas, Greg. So I want to open it up to the panelists to ask questions. And again, Brett, you did a great job last time pulling questions out of the chat. So what I want to, before we go to the discussion on this, I think I'm figuring out, I'm re-entering the poll questions, and I'm hoping that they stick this time. And so when we finish this discussion, I have a pop quiz for people that want the continuing education units that we'll see if it works. And then Greg, I'm not finding a question, not finding the questions that you sent. So if you want to dig one up and message it to me in the chat, then I will enter it into, I'll try to enter that into the creation of a poll for a little bit later in the morning. So questions for Greg?
It looks like we have one question here. So does foliar feeding become less effective later in the season when the leaves get dusty?
No, because they actually think that that's why foliar feeding works, is that it's the plants learn to get minerals from the dust. And so, no, I mean, I'm sure if they're really dusty, then it won't cover as well, but it stays on the leaf for a week. And every morning when the leaves start putting out moisture and CO2, it dissolves some and takes it up. So with fruit, most fruit, they recommend getting it in with apples, for instance, by marble size or so. And the reason for that is that the fruit undergoes cell division up to a certain stage, and then the rest of the growth is cell elongation. And so they've found that getting, for instance, calcium in, they want it during the cell division part, so they're stronger cells, and then when they elongate and the fruit gets larger and ripens, then it is already there. But when you want to take micronutrients and other things in, then no, I don't. We try and get it on, put it on, for instance, in wine grapes at veraison, which is the color change, which is another stressful time. And right after that, bunch rot and all these other things start stressing it, and the fruit becomes a potassium sink, and a lot of stresses come on.
Okay, and then another question, what's your opinion of the use of animal manures in orchards?
They should not be used, they should be composted first. But as most people know, there's very tight restrictions on the timing that you can use. It has to be 90 days away from it. So I'm not totally against manures, but it's not ready for plant use, and so it's a raw organic material, just as any fruit waste or leaves or things like that. And it's much more efficient to compost it first and then put it on the orchard. However, there is such a thing as sheet composting, where you spread it on and then inoculate it. But they've used a lot of manure over the years, and it just has a lot of problems. It also has a lot of leachable nutrients, and they can build up too.
Mm-hmm.
But if you know what you're doing, it can be done.
Another question here, is glacial rock dust or river bottom rock dust being used by farmers to provide trace minerals to the soil?
I'm not that big on hauling trace elements all the way from the Himalayas necessarily. Mm-hmm. And then rock dust, that's what limestone is, and that's what potassium is, and that's what a lot of micronutrients are. So if it's something that you can analyze and find out that's there, then it's good to use. I've seen people who get rock dust from local quarries, but really if it's local, their soils are derived from the rock dust. It's local.
Okay.
So it just depends on the analysis of the mineral.
Another one here, are there alternative irrigation techniques such as high pressure sub-irrigation that promote a better pattern of irrigation rather than drip pyramid?
I'm not a fan of subsurface irrigation. I have a whole nother show, and it shows the water barely gets up into the upper zone, which is where all the humus is and all the bioactivity is in that. I mean, even that top 4 to 6 inches of soil, that's where all your fungi are going to be. And so you're bypassing that. So you better do really well fertilization. And I realize it saves water, but no, the other thing is you don't get any leaching at all. And that's the natural way that these nutrients get down into the root zone.
Someone else is wondering, for your optimal citrus nitrogen program, for the 2 applications of compost, would compost tea do the job, or is actual compost added to the system?
Compost tea should be considered more an inoculant than a fertilization. You really can't get that many nutrients through the. Now, you can be using fish emulsion and other nitrogen sources through the irrigation, and then the compost tea is definitely going to help those digest and become available because it's an inoculant.
And that the fish emulsion could be co-applied with the compost tea.
Definitely, yeah.
As well as seaweed,
Yeah.
Question here from Robert Hill. How important is the water pH in the spray tank when applying foliar nutrients on citrus?
Well, I know copper, if it's too acid, can be a problem, but we throw a lot of rock powders together. We throw gypsum, potassium sulfate, kelp. I've never had a problem, for instance. Now, we have, this year, first year, we tried a product called Sil Matrix, which is potassium silicate. And that's very alkaline, that raises the pH. So I wouldn't want to later, when we put on a dipel, a BT spray, I'd want to buffer the pH down because that can affect some materials, some biologicals and everything. But the minerals, yeah, there definitely are some that, but that's the thing with the chemical fertilizers, you really got to watch that. You put on diammonium phosphate or something and then mix it with some calcium, it's going to start precipitating things. But most of the gypsums and the minerals that organic farmers grow, they just aren't that reactive.
Okay. And then how late in the season can a grower apply nitrogen to avoid excessive nitrogen in the fall flush, which encourages ACP?
You're talking about citrus now, okay. Gosh, it depends a lot on the form, because fish emulsion is one of the quicker ones to get in. So, I would have to defer that to someone else. I don't know. I don't know that you can, if they're talking about chemical nitrogen, I would do really low doses, but I would try and avoid right before that. Try and do it a month or more before the spring flush. But a lot of situations, nitrogen gets stored in the tree. I've seen vineyards where you decide to go on zero nitrogen for a while. That takes 2 years to get it out of the wood and slow things down. Citrus, it wouldn't take as long because it uses more nitrogen. But yeah, you'd probably just have to experiment with that, I suppose.
Okay, and then what's your opinion on using a surfactant as a soil conditioner to make water more wet?
That definitely could be good. And what it's going to do is make the water wetter and make it leach materials out down into the root zone, which is good. But then up where I am, where we get excessive rainfall, that's going to actually make your leaching of calcium and other minerals worse. So, but no, it definitely could have some uses, and also compost and other amendments, they also produce surfactants like that. That's one of the ways that they improve the tilth and aeration. So compost tea would help that too. But it can be valuable, definitely for leaching sodium and things, it can be valuable. And dissolving carbonates.
Great. That looks like that's all the questions we have for right now, unless anyone else. Ron, you're muted there. Yeah.
And thank you so much, both of you. Thanks
So,
for the great questions. We're about 7 minutes behind, Ron, but go ahead. And I want to make sure that Ben is in the queue. There. Okay, so go ahead, Ron.
So we're big fans of Dr. Elaine Ingham, and she says that you can balance the soil and ecology using a mineral approach and also from a biological approach. So her contention is that all the minerals that are needed in all the crops are present in all the soils that she's seeing. And it's just a matter of making them available by working with the biology. And so Gregg's presentation is really good as far as looking at a transitional strategy of getting your mineral balance while you're in the process of building the ecology. Thanks.